Let's look at how the shell or principal quantum number affects the values of the subshells. In the first shell, the energy level closest to the nucleus, only one subshell, the S subshell, is allowed. In the second shell, S and P subshells are allowed. In the third shell, S, P, and D subshells are allowed, and in the fourth subshell and higher, S, P, D, and F subshells are allowed. We will consider this in more detail, but I do want to point out that each successive shell allows more subshells and thus more electrons. Within a given shell, the S subshell is always lower in energy than the P subshell, is always lower in energy than the D subshell, is always lower in energy than the F subshell. This ranking only holds for a given shell. When we refer to subshells in a given shell, we use a coefficient to signify the shell. For example, 1s means the S subshell in the first shell. 2s means the S subshell in the second shell. 3s means the S subshell in the third shell. 2p means the P subshell in the second shell, and 3p means the P subshell in the third shell. Notice that I have ranked the subshells in each shell listed according to increasing energy. The 2s has a lower energy than 2p, 3s has a lower energy than 3p, which has a lower energy than 3d.